everyone, hope you had a lovely weekend. Welcome to our next lesson on electricity. So the first thing I would like you to do for me please is pause the video and have a go at these practice questions. They build on the equation we did last time, which was Q equals I times T. Okay, so let's go through those answers. Question number 1. What is the current flowing when a 2 coulomb charge is transported over 15 seconds? So in fact, what am I doing? Let me write, it's much easier here. Yes, that works. Woo. Okay, lovely. So I is Q divided by T is 2 divided by 15 is 0.13 amps. 2. What is the charge carried by a 10 amp current for 60 seconds? Q equals I times T equals 10 times 60 equals 600 coulombs. 3. How long does it take for a charge of 30 coulombs to be carried by a current of 4 amps? So T is Q over I is 30 divided by 4 equals 7.5 seconds. 4. What is the current flowing when a 15 coulomb charge is transported over 3 seconds? I is Q over T. 15 divided by 3 equals 5 amps. 5. What is the charge carried by a 45 amp current for 4 seconds? Q equals I times T equals 45 times 4 equals 180 coulombs. And 6. How long does it take for a charge of 168 coulombs to be carried by a current of 12 amps? T is Q over I. 168 divided by 12 equals 13 seconds. So hopefully you remember that, and that's all quite straightforward. The next thing we are going to do is have a little look here. A postman collects his letters to deliver from the post office. He then drops them off at the houses on the street, and when his bag is empty, walks back to the post office to pick up more letters. Now this is a model to explain electricity. So I want you to think back about what you learned about current and voltage. And we are going to try and explain this model and explain how it links to electricity. So the questions say, what represents the battery in this model? So remember that the battery provides energy. So have a think, read it through. Okay, hopefully you can see that the postman is collecting his letters from the post office. So in this case, the post office will represent the battery because it's the one that's providing the letters. Or providing the energy. Number 2, what represents the electrons? Now remember, electrons go round the circuit, picking up and delivering energy at different places. So hopefully you're happy that the electrons are represented here by the postman. And I know that because the postman is the one moving around the circuit, picking up energy or letters at the post office and then dropping them off at the houses. What represents the bulb? The bulb uses the energy, takes the energy from the electrons. So hopefully you're happy that that is the houses because that is where the postman is dropping off the energy. How could we show an increased current? Now remember, current is the rate at which the electrons are flowing. So I say you could increase the current by making the postman walk faster. And hopefully you can see that because that means they're going to speed round. How could we show an increased voltage? Now again, remember, voltage or potential difference is the amount of energy that the electrons are carrying. So if we want to increase the voltage, we need to increase the energy that our postman is carrying. So hopefully you're happy that we could do that by making increase the number of letters. That the postman carries. Right, so that's a model. Now the reason I'm talking about this is because I'm going to get you to make your own model. Now here they've just written it, but I'm going to get you to actually illustrate a model. So I'm just going to go on to another PowerPoint here. Let's just open this in Keynote. Okay, lovely. So, do you remember this model that you saw before? where you had the cell providing the energy, and this might be the parent, providing biscuits for the baby. The baby was represented by the bulb there, or the bulb was represented by the baby, should I say. The electrons were the plates that were going around the circuit, and the biscuits were representing the energy. What I want you to do is create a model and then illustrate it like this. So your model needs to have in it a battery, which gives energy, a bulb, which uses energy, electrons carrying energy, and then the energy actually, what are you going to show is the energy. So I've given an example here. Pizza delivery drivers picking up pizzas, energy from the pizza shop, battery, and delivering them to a house. The quicker they drive, the larger the current. The more pizzas they are carrying, the larger the voltage. So I want you to do, hang on, let me just, let's make this smaller. Okay, so you, as I say, need to draw your circuit, draw your analogy on there, and explain it. So you are going to, 1, draw circuit and model. 2, explain it, like my paragraph. So you can see that blue paragraph there. I basically want you to copy that, but put it into your own model. Now, if you're thinking, oh my gosh, what am I going to draw? Common ones I've had in the past, which work quite well, are food. That's nice and easy. You're basically looking for something, someone, to go somewhere, pick something up, and then go to another place and drop it off. And so that's your bit. So if you're struggling, think about your favourite food. Think about, we're all using Deliveroo and Uber Eats all the time. Or confession time, I am. I had a lovely sushi takeaway the other day. So start thinking, where can they pick stuff up? Where can they drop it off? You don't have to do food, but it's an easy one to do if you're struggling to think of anything else. And again, I want you to draw it something like this. So what I suggest you do is you screenshot this slide. So you've got that information, and then you screenshot perhaps the baby analogy. In fact, go for that one. And again, please just label what they are. So you might want to say electrons, plates, energy, biscuits, etc. So that's what I want. I want a drawing and an explanation. And if you can please do that this lesson and hand it in on the assignment. Please let me know if you have any questions, but I'm hoping that makes sense. All right, thanks everyone. Bye.